Scientific notation. The essential question of the lesson is how to convert numbers between standard form and scientific notation. So scientific notation is a way of representing very large and very small numbers. It also helps us compare and estimate large and small numbers. So let's look at two world examples. We have the distance between Earth and the Sun and the mass of one gold atom. So one number, the first one, the distance between Earth and the Sun is a very big number. It has many zeros, and it is 93 million miles away or between the two. The mass of one gold atom is a very tiny, has a tiny amount of weight, which means that it is 0. Many zeros, 327 grams. So in standard form, it is represented in a way that we've frequently seen it. And another way to represent these numbers in standard form is in scientific notation. So the first one, as you can see, it's 9.3 times 10 to the power of 7 miles. And the mass of one gold atom in scientific notation is represented as 3.27 times 10 to the power of -22. So one thing that you can discuss is what similarities and or differences do you notice between the numbers written in standard form versus in scientific notation? So one is that in standard form, there are many zeros. And in scientific notation, notice the number that is being represented has less digits, depending how big or small the number is. And both of the representation of scientific notations have a power of 10 with an exponent of 7, and one is an exponent of a -22. Scientific notation is used to eliminate the number of zeros needed to write a number. It is a product of a number between 1 and 10 and a power of 10. The number only has one digit to the left of the decimal point between 1 and 9. So if we take a look here, this is a number 3.25 times 10 to the power of 9, which is in scientific notation. So it has the coefficient 3.25. The number here in the ones can only be a digit between 1 to 9. So it can't be a 0 when it's in scientific notation. And it has a base with a power of 9. So there will always be a power of 10 to an exponent. Could be 1. So how do we convert standard to scientific notation? So step 1, we move the decimal point to the left until there's only one digit to the left of the decimal point. So if we look at the first number here to the right, we have 56,800. So technically there is a point there if we were to represent it in a decimal format. So starting from there, if I were to put a decimal point here, so move the decimal point to the left until there's only one digit left. So we want to ultimately place the decimal point right here. So to get it from there to here, we're going to move it 1, 2, 3, 4 places. So let's reread step 2. The number of places moved, so in this scenario it is 4, becomes the exponent in the power of 10. So we have times 10 to the power of 4. And notice that this number 4 is the same as this number. Okay, so these are the steps for converting large numbers. Now, if you wanted to convert small numbers, so it's a small number here to the right because it is smaller than 1, 0.000487. Step 1, move the decimal point to the right until there's only one digit between 1 and 9 to the left of the decimal point. So let's switch this color to red. I ultimately want my decimal point to be here so that I have one digit on the left of the decimal point. So I'm going to start from this decimal point and I'm going to move it 1, 2, 3, 4, 5. So that's 1, 2, 3, and 5. Let's look at step 2. The number of places moved is the negative exponent in the power of 10. So we moved 5 places, so the exponent here becomes negative 5. So we write 4.87 times 10 to the power of negative 5. Again, there is 7 here and 7 there. Let's look at C. So we start here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to write my number as 2.3 times 10 to the power of 9. And questions D, E, and F, we're going to now move. If you notice, the numbers are smaller. So these, we're going to represent very small numbers into scientific notation. So the decimal point is going to be moved to the right. So we start off with the decimal point being here. So it's 1, 2, 3, 4, 5. So the new point that we're going to write in scientific notation is 3.2 times 10 to the power of negative 5. Let's look at E. 1, 2, 3, 4. So we write it as 8.92 times 10 to the power of 4. For F, we start here at this decimal point. We're going to move it to the right. 1, 2, 3, 4, 5, 6, 7. So I'm going to rewrite the number 1.53 times 10 to the power of 7. Question 2. Convert each number from scientific notation to standard form. So I'm going to rewrite this number 9.78, and I'm going to move this decimal 4 spaces. 1, 2, 3, 4. Then I'm going to add zeros. I have to add 2 zeros. 1, 2, and my new decimal point, or if this were to be a decimal point number, it would be to the right. So my new number is 97,800. So question B, the exponent is 11 and it's positive, so we're going to move the decimal point to the right by 11 places. I'm going to rewrite the number here, 3238. We started off with the decimal point being here, and now I'm going to move 11. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I will fill those places now with zeros. 1, 7, 8. So my new number is going to be, I'll place the future decimal points so it's easier for me to rewrite it, will be 323,800,000,000. So this is a really big number. So let's look at C. I'm going to rewrite my number 1, 2, 3. We started off at the 1, and I need to move my decimal place 7 places to the right? Because it's positive. So that's 1, 2, 3, 4, 5, 6, 7. I will fill them with zeros. So that is 12,300,000. Question D. Notice that the exponents for all these questions is a negative. That means that the decimal place will be now moving to the left, and I'll be adding zeros to the left of the decimal points that we see here. So I'm going to rewrite my number, 28, and now I'm going to move 3 spaces to the left. 1, 2, 3. Fill the spaces. My new decimal point is here, and add another 0. Therefore, my new number in standard form is 0.0028. Let's look at E. Again, negative, it's going to move to the left. So I'm going to rewrite my number, 4.27, and I'm going to move my decimal point 2 spaces to the left. So I only need to add 1 0 here, decimal point, and 1 more 0. So this number from scientific to standard form is written as 0.0427. Let's look at F. So this one's going to be a very small number with lots of zeros. We're going to move the decimal point to the left by 9 places. I'm going to rewrite my number sort of to the right here because I'll need space to my left. The decimal point is here. And it's going to move 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll fill those spaces with zeros. It's a bit crooked. 1, 2, 3, 4, 5, 6, 7, 8, period, and then 1 more 0. So my new number becomes 0.12. I'm going to count the zeros. 1, 2, 3, 4, 5, 6, 7, 8. And then write the digits. 2238. 2238.